When we're presented with a similar figure problem, we're going to solve it with a proportion because similar figures are proportionally equal and because the directions say use a proportion. So when I go to set up my proportion, I do fraction equals fraction, and I figure out how I'm going to be consistent with these two figures. What I'm really looking at is I'm looking at this smaller triangle right here versus this larger triangle right here. And I know information about what I'm going to call the side of the triangle and the bottom of the triangle. So when I set up my proportion, I'm going to set it up as side over bottom. You could do bottom over side. It wouldn't really matter, again, as long as you are consistent. So if I look first at the red triangle that I highlighted, the side would be x plus 3, and the bottom is 7. When I look at the larger triangle, the side is 14, but when I consider the bottom of my larger triangle goes the whole way across. The gut reaction is to just say 5, but if I want the bottom of the whole triangle, I have to add those together and get 12. So there's my proportion. X plus 3 over 7 equals 14 over 12. And remember, the wonderful thing about proportions is I can solve them by cross multiplication. It gets rid of my fractions. So I take the 12 times the x plus 3, and I set that up with parentheses because I'm taking 12 times both. And that equals the 7 times 14. I now have a normal equation. I just go through and solve. So I distribute the 12. That gives me 12x plus 36 equals 7 times 14 is 98. It's a two-step equation now. Subtract 36 from both sides. That gives me 12x on the left. And now that equals 62. Divide by 12 to isolate the variable. And I end up with x equals 62 over 12. I want to look at two different ways we can simplify this. The first way would be just reducing it. Divide top and bottom by 2. So that would be 31/6. Or if I want to get a decimal, because it's easier for me to see, I can divide it out and I get 5.16 with the 6 part repeating. So those are two very possible answers and very accurate. So if I were to plug that value back in here for x, I could find out what the length of that missing side of my triangle actually is.